Thermal people, well, let's get real. Today's video is called Rankine Cycle, Real versus Ideal. Up until now, we've considered that the Rankine cycles have frictionless work processes. Wow, a life without friction, that would be both interesting and productive while being yet completely counterproductive. So anyhow, how do we account for friction in a Rankine cycle? Well, here's how we do it. We recognize that when there's a turbine and there's friction, we're going to get a little less energy out of the turbine because some of the energy has to overcome friction. When there's a pump, we have to put a little more friction in, a little more work in to overcome the H and overcome the friction. So turbine, we get less work, friction's working against us. Pump, we have to put in more work. That darn friction's always working against us. What we need to learn how to do is find new H's. There's going to be a new H at the exit of the turbine and a new H at the exit of the pump. Let's go find them. All right, first of all, what does it look like on a TS diagram? Well, if we start here with point 1, and we used to say point 2 is below point 1, straight below, well then where is point 2 going to be with friction? What does friction do to entropy? Yes, it makes it go up. So up is that way. Point 2 with an R for real is to the right of point 2. Now how do we find point 2 real? Oh, we better finish this sentence. The difference between real and ideal is friction in the work processes. So how do we account for that? Well, let's take a look. What's the difference between H2 and H2 real? Another name for H2 would be H2 ideal and H2 real. Let's go ahead and do that. H2 ideal and H2 real. H2 ideal, we find that the way we always have. Now we have to add one new step to the H2 process. We've talked about finding H2 is a process. So here's the new step. We add in something called the turbine efficiency. Now this is a mechanical efficiency. Basically what it's saying is I'm going to get less work out when there's friction than when there's not. For a turbine, I get less work out when there's friction than when there's not. Now the ideal work, we've found that before. That's H1 minus H2. Or now we're calling it H2 ideal. Well, what will the work be for a real turbine? It will still be H1 because the friction hasn't started at the entrance. Now it'll be minus H2 real. So here's our equation. Turbine efficiency equals H1 minus H2 real over H1 minus H2 ideal. Using our old method, we knew how to find H1. We know how to find H2 ideal. And the turbine efficiency will be given. The manufacturer will tell you this turbine has an efficiency curve like this. And then you can say, oh, well, if I'm operating between 1,000 psi and 2 psi, my turbine efficiency is 80%, 85%, something like that, given. So what's left? H2 real. It's the only thing we don't know. So the one new step to the process is to use the turbine efficiency equation to find H2 real. And pump efficiency works the same way. The efficiency of the pump, mechanical, and this is called mechanical efficiency. We learned something earlier called thermal efficiency. Two different cats. Turbine efficiency is a mechanical, it's just a ratio of works. Pump efficiency is a ratio of work of the pump. Now, the big one goes on the bottom to give us a percentage. And we said earlier, which is bigger, real or ideal? For a pump, real is bigger. For a turbine, real is less. So work of the pump real over work of the pump ideal. Excuse me. Work of the pump ideal over work of the pump real. Just a flip-flop of the turbine. I'll put a T here for turbine. All right, well, how do we find work of the pump ideal? Well, that was H4 minus H3 ideal. Let's take a look over here. Here's point 3. And point 4 ideal was right above it. Where's point 4 real? That way? Or that way? Friction causes entropy to go up. So point 4 real is to the right. Okay, so H4 ideal minus H3 over H4 real minus H3 is equal to the pump efficiency. This will be given. H3, we know how to find that. Piece of cake. HF at the pressure of the condenser. And we had ourselves a process for finding H4 ideal. We still use that same process. The only unknown is H4 real. When we use a real cycle, the work of the turbine, the specific work of the turbine, is now H1 minus H2 real. The work of the pump is now H4 real minus H3. This is the change. When we go to real, we account for friction. It gives us a more accurate result, and we use our H's with friction. And that is all she wrote.